Before I begin to work out this problem, be sure that you copy the question so that you are able to follow along, because the question will not appear throughout the entire problem. So once again, please be sure to copy the question before I start working out the problem. Writing out all the possible variables, P1, V1, T1, P2, V2, and T2. All right, so a sample of carbon dioxide gas occupies a volume of 3.5 liters. So that gives us our V1 because we know liters is a unit of volume. And then it says at 125 kilopascals pressure. So that tells us that we have 125 kilopascals for our P1. Then it continues on and says what pressure. So we're looking for the pressure, so that's going to be unknown. Would the gas exert if the volume was decreased to 2 liters? So since temperature is not mentioned in the problem, we know temperature is constant, so we can get rid of that. And the equation when temperature is held constant is P1 V1 is equal to P2 V2. This particular equation shows us that there's an inverse relationship between pressure and volume. So if you look at V1 and V2, you can see that there is a decrease in pressure. There's a decrease in volume. So since there's a decrease in volume, there's going to be an increase in pressure. That's what the inverse relationship means. As one increases, the other one will decrease, and vice versa. So now we are solving for P2. So we can go ahead and set this up so that we isolate P2 by dividing both sides by V2. So then your equation will be P1 over V1, P1 times V1 over V2 equals P2, because again, we have divided by V2 to isolate P2. So now we can plug in what we know. P1 is 125 kilopascals. V1 is 3.5 liters divided by V2, which is 2 liters. So with the way this problem is set up, liters will cancel, which will leave us with the unit of kilopascals. So you'll multiply 125 times 3.5. Then divide that by 2.0. Your final answer gives you 219 kilopascals. All right, and that is your final answer. All right, a second way to look at solving this problem is, so now we can look at this in terms of ratios. So if we look at the ratio between 3.5 and 2.0, you get 1.75, and so I do that by 3.5 divided by 2. 3.5 divided by 2 equals 1.75. So we can now take this number of 1.75 and multiply it times the pressure. So 1.75 times 125 will equal 219, which is the same answer we got the first time. And remember, since we're solving for pressure, your final unit must be included, which is kilopascals.